Hey everyone, and welcome. Today, we're going to dive deep into the world of Salesforce Apex. Our goal? To level up your skills to get you from writing code that just works to crafting code that's efficient, elegant, and something you can be truly proud of. Let's get into it. I want to kick things off with this question right here. It's from a developer looking back at their own work, and honestly, it's the guiding principle for this entire explainer. This is the question that separates someone who just writes code from a real craftsman who cares about quality. It's the standard we should all be aiming for.
All right, so let's set the stage. When we talk about Salesforce, a lot of people think it's just a CRM. But for us, it's so much more. It's a massive, incredibly powerful development platform where we build custom apps and business logic to solve really unique problems. And the language that makes it all happen? That's Apex.
So Apex is the backbone of pretty much all custom development on Salesforce. It's how you add those powerful features on top of the standard platform. Now, if you've ever seen Java, the syntax is going to look super familiar. But to really master Apex, you have to understand the very unique world it operates in. And this is it. This is the single most critical concept for any Salesforce developer: multi-tenancy. This one idea shapes everything we do, how we write our code, why certain rules exist, the whole shebang. So what in the world is it?
Well, let's use an analogy. I want you to picture the entire Salesforce platform as one huge, modern apartment building. It's a single structure, right? All owned and maintained by one company, Salesforce. Now, inside this building, you've got thousands of different companies living there. Each company gets its own, totally secure, private apartment. And that's their Salesforce org. All your data, your customizations, it's all locked away safely in your own space. But here's the crucial part. While your apartment is totally private, you are all sharing the building's core infrastructure. The electricity, the plumbing, the elevators. And in our world, that means the database, the memory, and the processing power. One tenant can't just crank up the AC and cause a blackout for the whole building. And that is exactly where governor limits come in. Think of these as the building's rules. They are strict limits on things like how many database queries you can run at once or how much processing time you can eat up. They exist for one reason: to make sure your code is a good neighbor and doesn't hog all the shared resources. This is why writing efficient Apex code isn't just a nice to have, it is an absolute requirement. Okay, so now that we get the why, let's get into the how. Every journey in programming starts with the fundamentals, and for Apex, that means understanding our core data types. At the end of the day, a data type just tells a variable what kind of information it's allowed to hold. Think of them as containers built for specific things. A string holds text, an integer holds a whole number, a Boolean holds a simple true or false. Now, the really special one here is the S object. This isn't just a piece of data. It's a direct link to a whole Salesforce record, like an entire account or contact object. It lets us work with real CRM data right inside our code. So, knowing the building blocks is one thing, but now we're going to move from just making code that works to making code that is great. This is where we talk about craftsmanship, about writing code that's easy to maintain, and maybe most importantly, code that other people can actually understand. I absolutely love this idea. Your code should never be a mystery novel that someone has to painstakingly decipher. It should be a clear story that explains what it's doing just by reading it. When another developer, or let's be honest, you in 6 months, looks at it, they should get it instantly. And the number one way to achieve that? It all starts with the name. Just take a look at this comparison. It's fascinating because both columns of code do the exact same thing. But look at the left side. CLS, AID, CS, C. What does any of that actually mean? You have no clue without digging in, and probably needing a bunch of comments. Now look at the right. Close case, account ID, cases to close, case to update. It reads like a sentence. The code is telling its own story. It's immediately understandable, way easier to debug, and a whole lot simpler to maintain down the road. And the rules for getting this right are actually pretty simple, but so powerful. First, be descriptive. Get rid of generic words like temp or data. Second, don't abbreviate so much that you lose the meaning. And third, just stick to standard conventions like camel case, where the first word's lowercase and every word after is capitalized. This little bit of discipline is what makes your code look professional and readable. All right, let's level up. We're going beyond just clean code now and into established design patterns. Think of these as proven, pro-level solutions to common problems. They help you write smarter,
more efficient code that totally respects those governor limits we were talking about earlier.
The singleton pattern is a perfect example of this. It's a fantastic technique for staying within your governor limits. Let's say you need to get some system settings, or maybe the current user's profile info. You might need that data in multiple places in your code. Well, a singleton makes sure you go to the database and get it only one time, and then it just reuses that same data for the rest of the process. That saves you precious, precious queries.
Now, here's a powerful shift in mindset I want to share. Instead of just writing code to solve today's problem, start thinking about building an application that can be easily configured and adapted for tomorrow. And the best way to picture this is to think of it like building an airplane cockpit. This illustrates the benefit perfectly. A pilot doesn't have to get out and rewire the plane just to change direction, right? They use the controls, they flip a switch. Your application should work the same way. Build it with configuration points, maybe using custom metadata that let an admin turn features on or off, or change how they behave. So when a client asks for a small change, it's not a whole new coding project. It's a simple configuration change. It's just a flip of a switch in your cockpit. That shows incredible foresight and provides so much more value. And finally, let's do a rapid-fire round of what not to do. These are the classic mistakes, the red flags. Number 1, never hard code record IDs. They will change when you move your code. Number 2, and this is a big one, never, ever put a database query or an update statement inside a loop. That is the fastest possible way to blow past your governor limits. Always, always handle potential errors gracefully with try-catch blocks. And finally, write tests that actually check if your code does what it's supposed to do, not just tests that run through the lines. Avoiding these common pitfalls is a giant leap toward becoming a senior developer. And that brings us full circle, right back to where we started. It's just not enough for your code to work. The real question, the one that defines your craftsmanship, is this. Is it clean? Is it efficient? Does it tell a clear story? Is it something you would be proud to put your name on? Because that is the standard of a true professional.